Hi, I'm Steve Brenneman at Aluminum Insights, and I'd like to take some time to tell you about why we exist. We're a startup trying to solve some industry problems that I experienced in my manufacturing company that uses a lot of extrusion. Instead of just talking about it, I want to show you what I mean. As a customer at my manufacturing company, I've been frustrated with a couple things that seem to be consistent in this industry. Let's first talk about inventory. Long, erratic lead times cause excess inventory in the system. Overselling during the slow times leads to long lead times when things get busy. We are going to leave capacity for overflow to keep lead times at a consistent maximum of 2 weeks. Also, one of the other problems is old and unreliable equipment. Let me show you some of our equipment. So, while I show you what our equipment looks like, I'm going to talk through the extrusion process with you. We start with 8-inch logs. Our press is 8-inch, and the logs come in 24 feet long, solid aluminum. So we queue the logs up in here, and then we put them in our laydown table and get them ready to go inside the furnace. So if you think about the extrusion process, it's really a lot like your Play-Doh fun factory when you were a kid. You press the Play-Doh through it, it comes out whatever shape is at the end of that press. That's exactly what it is happening here. It's just a lot more heat and a lot more pressure. We stack them here, prep them table, and the laydown table then begins to feed them into the oven. So this is the billet furnace, and as this starts to move through the billet furnace, the log will progressively get hotter. Once it reaches the other end, it'll be about 950 degrees. And that's the temperature, not quite liquid, but soft enough to be able to be pushed through the die. These are our dies. You can see some of them are single hole dies where we only have one part coming out. Like this one here, that's a single hole die. And we have others that have multiple holes. So the lighter the part, the more holes we have to put in to get a certain amount of material out. We can go up to 8 holes, all the same shape coming out at once. So this is the billet furnace. Again, as we move to the front, the gas burners, it uses natural gas. The gas burners get closer and closer as we move to the front. This is the power unit. Powers the hydraulic presses. There's 5 electric motors that power the pumps underneath. That creates the hydraulic pressure that then presses the material through the die. So you can see the hydraulic ram here. That is pushing through the container. The container keeps the billet hot and also keeps it contained. So that is very important to our process. In front of that container is the die, and that billet's being pressed through the container, through the die, and out the other end. So in a couple minutes, couple seconds, you're going to see the arm come back. The saw is going to cut off a shorter piece. We can go up to 47 inches. And we'll cut that piece off. The arm will come over, grab it. We'll put it in the press and keep running. The billet is about 2/3 done. As you can see, the ram moves very slowly. And so in just a couple seconds, the arm's going to go grab the next billet. Okay, so the billet comes out at a specified length. A saw blade cuts it while it's hot, so it's not really that loud. So the billet's cut. The arm's going to take it. It's now 950 degrees. It's going to place it in the tray. It's going to lubricate one end. so that the stem does not stick to the billet when it pulls back. You're going to see the ram pull back, you're going to see the container pull back, and it's going to shave off a small piece of the last billet. That's where all the skin and the impurities are. So we'll shave that off and that will get recycled. So now the next billet is being pressed. Now we're out here by the control panel and you can see the two extrusions coming out. This is a two-hole die, so the shapes are coming out and being cooled with just outside air. We also have the ability to cool with water to quench. So what you're going to see here is a mark where the last billet ended and the next one starts. And this saw is going to move with the part and cut right on that line. That line it's fused together, but it is not structurally sound. So the system knows where that line is going to cut on it. So these are, we have two pullers, one puller at the end, one puller with the saw. That's going to continue pulling the piece out, while the other puller deposits the longer pieces out there, and it will come make a handoff. So the smaller puller is going to take over the job. The larger puller with the saw is going to go back and wait for that next billet change, and the whole process will restart. As they cool, they're still somewhat soft. So the next part of the process is once they're cool enough, then we will stretch them to straighten them out, also align the fibers for hardening. So after the pieces are stretched, they move over to the side where they're going to move back over into the cut line to cut it to our customer's specified length. This is our cut line, and this is our saw stop. We can cut 1 meter wide apart. That's our air system that blows the chips out of the tubes into the back system, so you don't get chips in your tubes. So it moves through to the stop. And cut to length. So our handling system is automated in that we'll load the parts into the aging baskets. And the aging process will harden the pieces to whatever our customer specified hardness level. But as you can see, our system is automated and we won't touch the parts at all until they're on the other side of the aging furnace. So everything is loaded automatically. So after the baskets are filled, the basket then is full and moves out, and we get ready to load it onto the aging racks. So these are the full baskets. We do batches of up to 16 baskets, and that goes into the aging furnace, and that the amount of time it spends in the aging furnace is what determines its hardness. So this is our aging furnace, and like I said before, we can hold up to 16 racks, And when it comes out the other side, it cools. That's the end of the extrusion process. After that, it's just packing and shipping. So this is the end of the aging furnace line. The parts cool here, and as soon as they're cooled, we take them over to the packing area. And really the packing area at this point is pretty much manual. We're just taking them out of the baskets, we're packing them into cardboard or bundles that we get that our customers specify. And then once they're packed, then we move them over to the shipping area or to the warehouse and get them ready to head out or keep them in the warehouse for the future. That's the end of our process in this plant. So we also have fabrication equipment. Sometimes customers want shorter pieces than we can cut online or high tolerance cutting. So we do that here on this saw. We also have a CNC fabrication system. We call it a router, and we can make finished parts for customers. We can put holes in, we can route slots, we can put patterns in. All that's done here on our CNC router. And we also have a punch press. So we can do a lot of different fabrication for our customers, deliver finished parts ready to assemble. In order to have stable systems, we have to have a good maintenance system. A lot of plants may have a dirty plant or old equipment or equipment that's not maintained well, and that introduces a lot of ups and downs in lead times as well when equipment shut down. So we are building good systems in our maintenance department, keeping organized, good organization habits. We also have a board system where the team stands around the board and work through issues, track metrics, uptime, things like that, that keep our system running really, really well. And it's part of our continuous improvement culture. And here at Aluminum Insights, lean and continuous improvement is not just part of the work we do in the plant. We use things like leader standard work, where we can stay on top of systems, making sure that systems are followed through on. We can grade ourselves on how we're doing. We also want to keep the plant clean. So we have a system called Every Inch, Every Week. These carts are scattered throughout the plant, and makes it really easy for folks when we have a couple extra minutes can grab a broom and sweep. So we have the plant sectioned off in about 7 different areas, and the team in that area uses the system here to make sure that every inch of the plant gets swept at least once a week. So another way we keep lead times down is, you can see we have a cantilever system that acts as our warehouse right in the plant as part of our extrusion plant. That means we can have the warehouse right next to our production line. We can do quick ship daily or weekly. We can do stocking programs. That helps to keep our lead times much more stable. Okay, the other problem that I noticed in my manufacturing companies is that suppliers were not partners. We're focused on fast turnaround of new die shapes. We stay on top of it. Our target is to have new samples to you in 4 weeks of placement of PO for the die. We want to respond quickly to issues. We do email training to make sure we stay on top of our email. We do what we say. We also do combined improvement events with our customers where we walk their process, we walk our process, we put those two together in a map, and we look for ways that we can share in reducing our shared cost and making the whole process better, because we're all part of the same value stream that your customers buy products from. So we are trying to rewrite the rules of an old industry that seems stuck in its ways and internally focused. We have a really long way to go. After only 18 months in operation, we still have systems to build. However, we're building a continuous improvement culture, and that takes a long time to do. But we are a startup, so we're able to start at a pretty high level. So we will never stop improving while we keep our customer first mindset always in focus. Thank you.